Hi, hello. I am very happy to share with you how to derive the hydrostatic equation. dP dz equals minus g rho. So what at all does these values or these vectors represent? My dP is actually the change in the pressure, whilst my dz is the change with respect to z or the distance. My g is the gravity, my rho is the density of the fluid. And remember, a fluid could be compressible or incompressible. We all know that compressible fluids um they are type of fluid that changes significantly. There is a significant change when they are being subjected to a change in temperature or pressure. Whilst the incompressible fluids like or liquids or water, for these incompressible ones, their ability to respond to certain change in their density is high. So when they are being subjected to a change in pressure or temperature, there is a slight change in their density. Okay, so that was just by the way. So let's continue with our case. We all know that this is a cylinder. So I used a cylinder to derive our hydrostatic equation. So assuming a fluid is found within this cylinder or cylindrical shape, there are three forces: the one with the blue color, the one with the green color, and also the one with the red color. They are all different forces which is acting on a specific area. So when we take this force, the force is acting on a surface area, circular surface area. When we take this force, it is acting on this circular area. And also, lastly, when we take this force, it is acting on a particular area within this cylinder. So this cylinder is just a projection of the whole cylinder so that it will make our work easy. So let's begin. Here the forces are acting. We have the one which is acting upward, the one which is acting downward, and these two downward. So we should ask ourselves, what's the relationship between, a force and the pressure? There is a relationship between force and pressure. Is that force equals pressure times area. So my pressure should be force divided by the area. So quickly, the force due to the fluid. So we take these tiny particles as, let's say, assuming these particles are water particles. So assuming these particles, there is a force which is acting downward, and we can express this force in terms of pressure. And we know pressure in fluid is given by the gravity which is acting downward, the height, that's the z, then my rho, that's the density. These are the three main factors that affect pressure in fluids. Okay. Force equals the gravity times the distance, or the z, then the rho. Because we are expressing a force in terms of pressure, from this place my pressure is this. So substituting my pressure into this formula, we are getting the gravity times the z times rho times my surface area. The blue force here too is the force due to this change. There will be a small change in pressure. As I said previously, pressure at the top is different from pressure at the down. So we had the change to be P minus the small change, which is the dP. The dP, that's the small change. But it is being acted on a certain area called the E. And also the downward force, of which is pressure times area. So these are the three conditions we need to know. So this is my first condition. The upward forces are positive. The downward forces are negative. All forces in a small volume should be zero. Upward force equals pressure times area. Downward force. So the upward force from this diagram, I know that my upward force is this, pressure times area. Then my downward forces is the blue force and the one due to the fluid. Okay, so I think it makes sense. The downward forces are negative, so we are going to get my negative P minus the P A minus the gravity times the Z times the rho times the area. One thing we should note is that we derived the equation by using the Cartesian plane. So the upward force which is moving up is positive, and the downward forces which is acting downward is negative. Now all forces should add up to 0. That's force in a small volume. So from our previous one, we saw that the first pressure was this, then this was the pressure due to the fluid. So when we sum them, we are getting, when we sum the whole of this, then dividing through by A, we are getting P minus P plus dP minus G times 0 equals 0. Mind the P equals gravity times Z times rho. But Z is a small change in height. So the small change in height. So we can donate the Z as the Z. It's a mathematical expression that shows the pressure at different height. Okay, so quickly, mind the P equals negative gravity dz times rho. So this is the rho. Okay. Or someone may ask, why is it that it is negative? It is negative because the gravity is acting downward. That's the gene. It's acting downward on the negative y direction. That's why the gravity is 0. The gravity is negative. So wrapping up, we can group all the right hand side onto the left hand side, then equate it to 0. So doing that, we had this. But the question says we should show that the hydrostatic equation is this. So we can write it at this from here or here. Thank you very much. Please, I need your support. Help me. I hope you enjoyed this lesson. Thanks for your time.